All right, today we're jumping into the chemistry that secretly connects things like perfumes, plastics, and even the food you eat. And it all boils down to one amazing group of molecules: carbonyl compounds. It kind of sounds like the start of a riddle, doesn't it? A beautiful perfume, a tough piece of plastic, and a simple food preservative. I mean, they seem like they're from completely different worlds, but chemically, they're all part of the same secret club. And the answer to that riddle is the carbonyl group. It's this incredibly simple little structure, just a carbon atom double bonded to an oxygen atom. Think of it as the family name, the shared DNA that ties together a huge, diverse group of compounds. It's the core engine that gives them all their unique abilities. Now, within this big family, we're going to focus on three major players today: the aldehydes, the ketones, and the carboxylic acids. Just imagine them as three siblings, each with a very distinct personality, but all sharing that fundamental carbonyl DNA. First up, let's get to know the aldehydes. If this were a real family, aldehydes would be that super energetic, highly reactive sibling, the one who's always ready to jump into action and start a chemical reaction. So, what's their secret? What actually makes an aldehyde an aldehyde? Well, it's all about what's attached to that main carbonyl carbon. For an aldehyde, that carbon is bonded to at least one hydrogen atom. And that little detail right there is the key to everything about its behavior. This really shows off their secret weapon. You can see it in the formula. There's a hydrogen atom attached directly to the carbonyl group. And having that single hydrogen there makes the whole molecule much, much easier to oxidize, which is just a chemical way of saying it makes them incredibly reactive. And when it comes to naming these things, you'll see a couple of styles. You've got common names, like formaldehyde, and then the official scientific names that end in -al, like methanol. It's really just like having a nickname versus your full formal name. And believe me, this isn't just some abstract chemistry stuff. We use aldehydes everywhere. Formaldehyde is a super effective preservative. They're absolutely essential for making plastics and resins. And that sweet almond-like scent in some perfumes, yep, that's an aldehyde called benzaldehyde. All right, next up in the family photo, we have the ketones. And if aldehydes are the reactive sibling, ketones are the cool, calm, and collected one. They've got that same carbonyl core, but their chemical personality is way more reserved. The reason they're so different is all in the structure. For a ketone, that carbonyl carbon is kind of tucked away, sandwiched between two other carbon atoms. See the difference? There's no easily accessible hydrogen atom, like we saw with the aldehydes. And that structure is exactly why they're so stable. That central carbonyl group is shielded on both sides by other carbon groups. Without that exposed hydrogen atom to react, ketones are just structurally more stable and way less reactive. They're built to last. Naming for ketones is pretty similar, but the official IUPAC suffix is -one. So the common nail polish remover everyone knows, acetone, is officially called propanone. And that incredible stability is precisely what makes ketones such fantastic solvents. That's acetone's whole job, right? They're also really important building blocks in the drug industry and are used to make durable polymers like Perspex, which you probably know as plexiglass. And finally, let's meet the powerful cousin of the family, the carboxylic acids. They take that basic carbonyl group and bolt on an extra functional piece to create something totally new and, well, really influential. A carboxylic acid is defined by what's called the carboxyl group. As you can see, it's a hybrid. It's got the C double bond O from the carbonyl group and a hydroxyl, or OH group, attached to that same carbon. And that little combination is a total game changer. Now here's the crucial part. That COOH group is the source of their power. The hydrogen on the hydroxyl part can pop off really easily as a proton. And in the world of chemistry, donating a proton is the very definition of what makes something an acid. Their official names end in oic acid, and I can almost guarantee you know the second one on this list: acetic acid. That's the main ingredient that gives vinegar its super sharp taste and smell. Now, here's something really fascinating about these acids. They have incredibly high boiling points. Because of that special COOH group, the molecules can form these really strong connections with each other, almost like they're holding hands. These links, called hydrogen bonds, make them cling together so tightly that you need a ton of energy to pull them apart and get them to boil. Okay, so we've met the whole family. Now let's bring them all back together, put them side by side, and really compare what makes them tick. Really, the most important comparison to remember is their reactivity. Aldehydes, with their exposed hydrogen, are always ready for action. They're the reactive sibling. Ketones with their shielded carbonyl group are the stable, more chill one. It's just amazing how that one small structural difference completely dictates their chemical personality. So, this brings up a really common question about the relationship between these family members. Can the superreactive aldehyde actually transform into its powerful cousin, the carboxylic acid? And the answer is a big, resounding yes. Absolutely. Because they're so reactive, aldehydes are very easily oxidized, and that process literally converts the CHO group into a COOH group. It's a perfect illustration of the direct chemical pathway connecting two members of our carbonyl family. So, at the end of the day, why does any of this matter? Because these compounds are, without a doubt, fundamental building blocks of our world. They are central to biochemical processes happening in our own bodies. They form the plastics and solvents we use every single day. They're essential for creating life-saving medicines, and they even flavor and preserve our food. From perfumes to polymers, it's pretty clear the carbonyl group is one of chemistry's most versatile and powerful master builders, which really makes you wonder, what incredible new materials and medicines will we build with it next?